Hello everyone, welcome to Fantastic Solution. So today we'll be solving again more lead code medium problem on dynamic programming. So this is the minimum path sum problem, and let's read the problem first and try to see now what the problem says and how we can solve this. So the problem says given an m cross n grid filled with non-negative numbers, find the path from top left to bottom right corner. So you have to find a path to reach from here to here, and which minimizes the sum of all the numbers along. So on each cell we will having numbers, and if you're going from here to here, or let's say total number of paths, what could be all the numbers, then we need to minimize the sum. And it also says note you can move either down or right at any point of time. So these are the only two options. So if someone is at this point, they can move either right or down. They cannot go top and left. So these are illegal moves, like this is not allowed. So we have to give minimum path sum for each cell. We already have a like fit is given there. So we need to find out the minimum sum which will take during that path. So it says this path would be the minimum because the sum is minimum in this during this path. So if C 1 plus 3 4 4 1 5 5 plus 1 6 6 plus 1 7. If we take this path, so it will have 1 plus 1 2 2 plus 4 6 6 plus 2 8, right? So this one is coming 8. It will just go here. If we are taking this path, so it will be 1 1 plus 2 plus 5 7 plus 8, right? So everyone is having more path as compared to this path. So that's why this path is the valid path uh, as per this problem. So if you see, we have already solved the similar problem named as unique path, where robot started from start to end. And what we had to do, we had to give the total number of ways robot can go from here to here, and we're storing all the values here, right? So this was a 3 cross 7 matrix. Let's just go and see how did we solve this. So if robot was here, right, at this start place, if robot was a start place, right? So the total number of ways to reach to this cell, only one way, right? He can take only right direction. So that's why we updated the first values with 1. Similarly, from here to here, again, robot can take only one way, right? That is right. That's the only way. So we updated it 1. Like robot cannot do go right, down, right, and this up. So this up move is not allowed. So that's there is only one way to go there. Similar to way again from here to here, robot can only go right, and that's the total number of way was only 1, right? So if you see clearly in the very first row at each place, right, from start to end as well, from here to here, robot has only one option, which is right move. So what we did, we updated every cell with the 1. So 1 basically says total number of ways to reach to this particular cell from the start point. And if you see the same ways for the first column as well, the robot has only one way, that is down, and from here to here as well, robot has only one way, which is down. So that's why we updated with 1. So first when first column we had updated with 1. If you say this is the program for that. And what about if we are not into the first column? So if let us go and see. So at this cell, how many ways are there robot can take? So robot can come from top or from this left side, right? These are only two ways. So robot can follow this path or robot can follow this path. So these are the only two ways robot can take. So here we have total number of ways 1. Here we have total number of ways 1. So the sum of these two are basically 2 got updated here. Now for this cell, here robot can come from here or here. So to come here, robot has only one way, and to come here, robot has two ways. So total number of way to reach this path would be 3, right? That's why we updated with 3. So what if you clearly see now what we did to any other cell to reach that, we had what we are updating for each cell, the previous row and previous column values. So that's how we updated the values. So similarly, let's say if robot were to come to this place, right? Robot can come from here or here. To come here, we have total number of ways 3. To come here, we have total number of ways 3. The total number of way to come to this cell would be sum of this and this, right? 6. But now let's see and see what is the difference between this problem and the previous unique path problem. So this problem is not asking us to find all the total number of ways. It's asking us uh, in the previous problems we didn't have any weight for every cells, right? So it's asking us to find, it already has given the weight in those cells and trying to say find the minimum number of ways to reach to any cell. That should be our goal now. So, and the weight should be minimum, right? So we know the very first row and first column. First row and first column, we were updating with one, right? There is only one way to reach these cells. So the minimum paths, so minimum weight, like since we know that to come to this cell, I'll have only one way. So that's why if I'm coming from here to here, I can just add whatever those numbers are. So here it would be like 4. If I want to, let's say, if I want to follow some path, like come from here to here, so my weight in this cell would be like 3 plus 1, 4, right? And if I'm coming from again from here to here, I have only one way. I can come from here to here only. So I had previous set 4. 4 plus 1 would be 5. I'm just going to update what we are doing it here. So to come here to here, we are just doing 1 plus 3, which should be 4. And to come from here to here, we'll be doing 4 plus 1, 5, right? Because we have only one way to come to this cell from here to here. So whatever the weight we got here and the new weight which we have here, we have to just update it. Same case would be going to the first column as well. In first column, from to reach to this particular cell, we have only one way. We can come from this place. That would be 1 plus 1, which would be nothing but 2. And to come to this cell again, we have only one way from top. We can just come into this bottom way, right? So this would be 2 plus 4, which would be 6. Now, what about this place? So here we can come from either here or here. But now our goal is to minimize, this weightage path. Whatever the weightage it has been given to us, we have to minimize the total sum. So if we are coming from this place, the weight will be 4, but here the weight will be 2. So the greedy approach we can follow. Let's choose the whatever the minimum value we have. So for this particular cell, either we can choose 4 or 2. So we'll be choosing minimum of 4 comma 2, which would be 2, and plus the current cell weight, which is 5. That would be 7. So here our weight is nothing but 7. What about this place? So this place, our now weight would be minimum of 6 comma 7, which would be 6 plus current weight is 2. So that would be 8. So here we got 8, right? What about this place? So this place, we can come from either this place or this place, right? So we have weight minimum of 7, comma here we had 5, right? So minimum would be 5 plus the current weight was 1, which is 6. So here we got the total weight as 6. Now to come here again, we'll have two ways. Either we can come from top or we can come from the left side. So minimum of 6 comma 8, which would be 6 plus the current weight, which was 1, equals to 7. So that's why our answer is 7 finalized, right? And you can see we had an answer there, 7. So we followed the same, same path. So if you see, to reach here, we came from this side, top. So to come here, the 6 came from this 5 plus 1, right? So we just followed this path, and that's what, the path has been given into that, our example. So let's quickly try to write the solution for this one, the similar approach, what we just discussed, and see if you're able to pass all the test cases. So let's try to activate the loop. s should be less than grid dot length I plus plus. And I would always recommend to go through this video solutions because that's kind of our main, like this would be helpful to solve the all the variations of the paths. Let j equals to 0, this will be less than grid of I dot length comma j plus plus. So what we are doing the very first thing, the similar approach we followed right in the previous thing, we're just updating the total number of ways for the first row and first column. So here again we are going to update the first row and first column with their weight. And what we had to do, we had to just update to the previous cell value. That's it, right? So if I equals to 0, so we'll be doing grid of I comma j equals to grid of. So when we are coming to this place, grid of I comma j equals to plus of the previous cell values, right? So grid of I comma j minus 1. Similarly, if j equals to 0, current to the first column, then grid of I comma j equals to grid of I comma j, what was the current value, plus grid of I minus 1, previous cell value, previous row value, comma j. That's what we did. And now for other things, what we are doing, if I is not equals to 0 and j not equals to 0, then what we are doing, we are adding current value. So grid of I comma j plus on the top and from the left, whatever the minimum values are there, we are just going to use that thing. So because to come to this place, either we can come from the top or we can come from the left, right? So we are, whatever the minimum weight we are getting from either top or left, you can see whatever the minimum weight to come to this place we are getting from 4 or 2 top or left, right? We're just going to use that. So math dot min. Let's just update grid of I comma j comma grid of I comma j. So if we are at this place to come from the top, it should, if you're at this place to come from the top, it would be grid of I minus 1 comma j, right? And to come from this place, it should be grid of I comma j minus 1, right? That should be enough. And once this for loop ends, so return grid of m minus 1 n minus 1. Okay, so we haven't defined the m and n. Let's define that as well. Let m equal to grid dot length and let n equal to grid of 0 dot length. It should be cosine. So now our final solution is always getting stored at this label. So we can see our final solution was stored, the 7 was at this particular label. And we just need to return our final solution. So let's try to run it. So what it says, grid of I equals to 0. Here we have to update if chain not equals to 0. Let us see, because we are adding for the second column onwards, and this one would be rid of j, right? This would be I equals to 0. This would be j should be to 0. I not equals to 0 and j not equals to 0. Let's try to run it now. Good. So the solution got accepted. Yeah. So what we were updating at, like, we're just excluding this first 0 comma 0. After that, 0 comma 1 or 0 comma 2, we are updating those values with the previous sum, right? That's what we were doing it. So the condition is same. If I equals to 0, we are in the first row and not into the first column, right? That's what we did. Then we are going to just update all the values of the grid with the previous cell sum. And similarly into the first column as well, we just updated those values. And for if you're not into the first column, so we can just add them with the whatever the minimum we are getting either from the top and left. And then at the end of the day, the final sum would be stored at m minus 1 and minus 1. You can just submit it and we'll see. The solution got accepted.